All right, guys, for this problem, it says a person 6 feet tall is walking towards a street light 20 feet high at a rate of 7 feet per second. At what rate is the length of the person's shadow changing? Well, if you notice from the diagram, the person is 6 feet tall. The lamp post or street light is 20 feet tall. And then my x and y variables describe distance. X would be the length of the shadow, and y would be the length of the distance between the person and the street light. Now, notice, guys, if we're walking towards the street light, that means that this value y is decreasing, right? So the rate of change that is occurring here is going to be negative. If you also notice, it says walking towards that streetlight at a rate of 7 feet per second. So the change in the y with respect to time is negative 7 feet per second. And what it wants you to find here is what is the length of the person's shadow changing. So it wants to know what the derivative of x with respect to time is. Okay, well, you would not use Pythagorean's theorem for this problem. You would actually use what we call similar triangles to help you solve this. Because if you notice, you have a big triangle, which would be with the lamppost 20, and then y plus x, because that will be the distance here. And then you have a smaller triangle with his height, which is 6, and this is just x. So we have similar triangles. And what we're going to do is we're going to set up a proportion. So in other words, I'm going to have 20 is equivalent to 6, and y plus x is equivalent to x. So I'm going to have 20 is equivalent to 6, and then y plus x is equivalent to x. All right, now to solve this proportion, not really solve it, but just kind of work it out, I'm going to cross multiply. So I'm going to get 20x is equal to 6y plus 6x. And I notice that I have an x on both sides, so I'm going to subtract 6x, so that'll give me 14x is equal to 6y. Now I'm going to do implicit differentiation with respect to time. So the derivative with respect to time of 14x equals the derivative with respect to time of 6y. The derivative of 14x with respect to time would be 14 dx over dt. The derivative of 6y with respect to time would be 6 dy dt. Now, if you remember from the original problem, the change in y with respect to t was negative 7, so I'm going to plug that in. So 6 times negative 7, so that would be negative 42, is equal to 14 dx over dt. And remember, dx over dt is what you're asked to solve, so divide by 14, and so I'm going to get dx over dt is negative 3, and then that would be feet per second. In other words, his shadow is decreasing because it's negative. It's decreasing at a rate of 3 feet per second at that instant.